You know, as if you needed another excuse to get to the gym, work out, and oxygenate the body. We're learning so much about how our body works and the complexity of our body. Two of the other videos here on Body Doc discuss some of this complexity. One is a video that I made about telomeres, which is a fascinating subject involving the tips of all your chromosomes. So I didn't make that video because I'm in the business of doing something with telomeres, but I wanted everybody to understand the complexity of the body. I find so many people trying to figure this stuff out, simplifying the body's biological processes. You can't do that, guys. It's not that simple. And to oversimplify it is going to have you buying things and doing things that are just simply wrong for you. So if you step back and you appreciate the complexity of the system, you're going to really do yourself number one, you're going to save a lot of time and money and a lot of grief. And you're going to have a really more of a truer, more beautiful understanding of the complexity of your body. That's what Body Doc is all about. A bit of a humble step back from where we've been going in a reductionist paradigm that has led us to believe that we can simply fix all these little small parts and then come back with medical advances to treat every condition that's known. But what we are learning in another video I have here about epigenetics is that our genome is not a one-way street. It isn't sort of a set of instructions. Granted, it's a very powerful element of who we are. One only needs to look at your mom and dad and your brothers and sisters and other family members to see the phenotypic similarities that you have with your family. And you're also going to have a lot of processes that are very similar to your family as well. So just let's not discount the power of your genetics and the power of what was created when your mom and dad made you. But from that point forward, the way the body seems to function in a regulatory fashion is both driven by genes, but also by epigenetics. Epigenetics being the thoughts that you have, whether or not you have loved community in your life, whether or not you're eating the right foods, whether or not you're active. Today's video discusses one of the really cool things. The Nobel Prize last year in medicine in 2019 was given to a few researchers that studied tumor formation and what happens in the body with low oxygen levels. And I thought this was really cool because a lot of you guys are dealing with exercise injuries, which is the focus here of Body Doc. And exercise injuries heal a lot better in a healthy body. So over the years of practicing, I've learned that if I can treat patients on two different levels, one, to help them understand the actual injury they came to see me with, and oftentimes it's quite simple, like a tennis elbow or a low back injury, but also to promote general health, I'm going to have better outcomes here in my office. I'm going to have people leaving this office here simply from a building my business standpoint that are saying, hey, I went to see Dr. Rick and I'm feeling so much better and I'm now behaving better, I'm eating better, and my injuries are going away and they're not coming back. So the point obviously is to not only help you guys to understand the injury process itself, but all the sort of, I think, related concepts that are involved with your body and its self-healing abilities. So if you want a great self-healing body, this is a great video for you. So we found normoxia. Normoxia is the state that the body would be in when normal amount of oxygen is being breathed in and being delivered about the body. Many athletes over the years have really become interested in a concept that deals with erythropoietin. So if you were to go into high altitude training like our Olympians do in Colorado, you would find with the low oxygen levels in the air that the body would be changing in adaptive systems. And one of the things that was discovered many years ago was a hormone called erythropoietin would be starting to be produced, thereby stimulating more red blood cells. And in the presence of more red blood cells, the low oxygen levels in the air could have more cells to absorb it and therefore normalize the oxygen state of the body. But what these researchers found was way more profound than that. Yes, EPO is one of the variables, but we also realized that tumors and inflammatory states also become very contorted in a low oxygen environment. So we've got two things here. We've got normal and we have hydroxyl groups. When you breathe in oxygen, it's delivered to the tissues. It's hydroxylated to form these hydroxyl groups. And in a beautiful little way, it leads to proteosomic degradation. So the cells are never kicking off this cycle here and never going to the cell nucleus where your genes are. And there's nothing taking place there because there's enough oxygen to perform all the processes. And I'm simplifying this madly here, of course, because it's quite complicated. You'll see that I have got the actual chart from that Nobel Prize thing, and you can, if you'd like to, read into it further and understand this in a deeper, more profound way, by all means do. That's what Body Doc is all about. But I thought I would take some of the salient details of this process and break it down for you. And here you see hypoxia, or low oxygen levels. So if we're not doing anything, we're living in altitude, or we're just simply very sedentary, the amount of oxygen that you'd be drawing into your body is low. And what does your body do? Well, it turns genes on. It starts doing things in an adaptive response to a low oxygen environment. Now, over time, the hypoxic condition leads to a factor called HL1, and it goes into the genome, and it attaches to roughly 300 genes that lie in the cell nucleus. And what we found is this is stimulating tumor formation and inflammatory states in the body. So the two takeaways are, for prevention of cancer and also for the better healing of your injuries, by all means, oxygenate the tissue. That's the takeaway from this research. Nobel Prize last year, fantastic stuff. Keep on learning. The more you know, the less you guess.